Welcome everyone. Today we're going to clearly understand how AWS runs containerized applications at scale using ECS and Fargate. This lecture will walk you through the core concepts step by step so you can see how everything fits together in a real-world setup. Today, we will discuss these topics: AWS ECS, Elastic Container Service; AWS Fargate, Serverless Containers; Task Definitions; ECS Services and Auto-Scaling; Production ECS Architecture. AWS ECS, Elastic Container Service. Amazon Elastic Container Service is a fully managed container orchestration service that runs Docker containers at scale. It runs, scales, and manages Docker containers without you needing to operate a Kubernetes cluster. ECS has two launch types: Fargate, where AWS manages the underlying compute entirely, and EC2, where you manage a fleet of EC2 instances as the cluster. It integrates with ALB, IAM, CloudWatch, and VPC. ECS is a better choice than Lambda for long-running workloads, when execution time is more than 15 minutes, when a custom runtime is required, or when running a containerized web server or background worker. AWS Fargate, Serverless Containers. AWS Fargate removes all EC2 infrastructure management from container workloads. You define task CPU and memory, and AWS handles infrastructure. There are no EC2 instances to provision or patch, no clusters to size, and no bin packing to optimize. You pay per task second based on vCPU and GB of memory. Each task gets its own isolated compute environment. Fargate Spot is available for up to 70% savings and is suitable for batch jobs and non-critical workloads. It also supports ARM64 via Graviton for cheaper compute. Task Definitions. Task definitions are versioned JSON blueprints that describe how to run your container. They specify the container image, CPU and memory allocation, port mappings, environment variables, secrets, and log configuration. The container image can be stored in Amazon Elastic Container Registry or Docker Hub. 2 IAM roles are required. The execution role allows ECS to pull the image and write logs to CloudWatch, and the task role allows your application to call AWS services. Secrets should be injected from Secrets Manager and never hard-coded. Always configure the AWS Logs log driver for CloudWatch. CPU ranges from 256 to 16,384 units. Memory from 512 megabytes to 120 gigabytes. An architecture can be x86 or ARM64. Every update creates a new revision, and old ones are kept. ECS services maintain a desired number of running tasks at all times, and replace failed tasks automatically. They register tasks with an application load balancer target group, and route traffic after health checks. Application auto-scaling adjusts the task count based on CloudWatch metrics such as CPU utilization or custom metrics like SQS queue depth. Deployments use rolling updates to replace tasks gradually. Blue-green deployments are supported via code deploy for zero downtime. Minimum healthy % should be set to avoid full outage during deployments. Production ECS architecture runs Fargate tasks in private subnets with no public IPs, and all inbound traffic flows through an application load balancer. Container images are stored in ECR instead of Docker Hub. Logs and metrics go to CloudWatch using the AWS Logs driver. Secrets are pulled from Secrets Manager at task startup. CPU and memory limits should always be set. CI/CD pipelines using Code Pipeline and Code build images, push them to ECR, and trigger deployments. Container insights should be enabled to get per-task CPU, memory, and network metrics without application instrumentation. To conclude, Amazon Elastic Container Service provides a fully managed way to run and scale Docker containers without managing complex infrastructure. With AWS Fargate, you eliminate the need to handle EC2 instances by simply defining CPU and memory requirements. Task definitions act as the blueprint for running containers, while ECS services ensure availability and scaling through automation. In a production setup, integrating services like Amazon Elastic Container Registry and CloudWatch, along with proper networking and CI/CD pipelines, creates a scalable, secure, and efficient architecture for modern applications. Thank you for watching.